Next question. Find the area of the region whose boundary is defined by the function um, y is equals to x squared and y is equals to 2 minus x. So, start by sketching. Produce a better sketch. So, what we have here is quadratic function. Can produce something better than that. Better quadratic function. Yeah, something like that. That's better. Linear function. And the linear function is y is equals to 2 minus x. Quadratic function is y is equals to x squared. So find the area of the region whose boundary is defined by this function, these two functions. So what we want is this. What we need to find that are the x values at the points of the intersection where the two curves meet. So points of intersection, we're just interested in the x values. So 2 minus x is equals to x squared at the point of intersection, which means that x squared plus x minus 2 is equals to 0. X plus 2, x minus 1 is equals to 0. So x is equals to negative 2 or x is equals to 1. So x is equals to negative 2 or x is equals to 1. Once you have that, we're almost done with this question. We just need to find the definite integral. So we'll find the definite integral. So the area will be 1 negative 2, 2 minus x squared. That will be the integral from negative 2 to 1 of 2 plus 2 minus x plus x squared. Which will be 2x minus x squared over 2 plus x cubed over 3. So area will be 2 minus a half plus a third minus negative 4 minus 4 over 2 minus 8 over 3, 11 over 6 plus 26 over 3, which is equal to 21 over 2. That's it. Number 5, find the area of the region whose boundary is defined by these lines. Start by sketching these exponential functions. So we have our exponential functions meeting at the y-axis. That's y, that's x. This one will be y is equals to e to the power x. Y is equals to e to the power negative x. The other boundary is x is plus minus 1. So that x is equals to 1 and x is equals to negative 1. So the area that we are interested in is that what I'll do is this. This area is equal to that. So I'll just find out the area of A, double it, to find the total area of these two guys, of these two regions, and B. So step one, just find the definite integral. So area will be integral from 1 to 0 of this one is e to the power negative x dx, which will be negative e to the power negative x 1 0, which will be negative e to the power negative 1 minus negative e to the power 0. That will give me negative 1 over e plus 1, which is equals to 1 minus 1 over e. So the area of A and B will be 2 multiplied by 1 minus 1 over e. That's it. Number 6, find the area of the region whose boundary is defined by the functions y is equals to 1 over x, y is equals to 2 over 3, and x is equals to 3. So what we shall do here is start by sketching. This function here is y is equals to cube root of x squared, which means if you plug in any positive value, you'll get a y value for any positive value of x, and you'll still get a y value for any negative value of x. So this function will look something like this. This side, it looks something like that. On this side, it will also look something like that. So this is y and x. This is y is equals to cube root of x squared. The other function is 1 over x. So that one, on this side, you have something like that. On this side, you have something like that. The last one, x is equals to 3. X is equals to 3. Now, we really don't know where x is equals to 3 here, unless we find what that is. So we need to find the coordinate where the two functions meet. So at point of intersection, what we have is 1 over x is equal to x to the power 2 over 3, which means 1 is equals to x to the power 5 over 3. So x is equals to 1. So here x is equals to 1, which means that x is equals to 3 will be somewhere here. Good. So we have our sketch. Now we want to find the region that's defined by these three functions. So that region will be this one here. Okay, so that's the region that's defined by the three functions. So what I'm going to do next is to try and find the area of this region. I'll divide it into two parts. I'll call this A and call that B. Find the area of A, find the area of B, and then add them up. So area of A start with A. So the area of A will be the integral 3 to 1 over x dx, which will be ln x, ln absolute value of x 3, 1, which is ln 3 minus ln 1, which is just ln 3. Area of B will be 1, 0, x to the power 2 over 3 dx, which will be x to the power 5 over 3 over 5 over 3, 1, 0, which will be 3 over 5 x to the power 5 over 3, 1, 0, and that will just be 3 over 5. Plug in 1, you get 3 over 5, you get plug in 0, you just get 0. So the total area will be 3 over 5 plus ln 3. Next question, it's a GDC question, calculator question. So the first thing that we need to do in this question is to sketch the function, our calculator. So let's do it. Y is equals to, let's just clear this. Plug in cos 2x plug in ln x minus 1. So if I graph it, it looks something like this. Let me try standard window just to get a clear picture of what's going on here. It's too small. So what I can do is I can zoom. Just want to select this particular area that seems to be having a lot of activity. Okay, there. Good. So what I have is this function here. I just take this off. So I have this function. This is basically the graph of this. Now, I'm being larger. Okay, that's better. What I need to find is this one looks like this is actually the cos 2x. The other one, it's a logarithmic function. I need to find this coordinate here. Use a blue one. I need to find the x value here. I need to find the x value there. I can find this as well, but there's no need. I just need that and that. Why? Because all I need is the area of this and this area. Okay? I need the area enclosed by these two curves. So that's all I need. And I need these two x values, all right? The extreme ones. That's it. Anyway, so to find these x values, I'll come back to my calculator. So second calc intersect, you know the drill. First curve, second curve, that will be 1.39. So 1.39. The other one, second calc, .4 to three significant figures, 3.4. So my area here will be, just fit it here. So area will be the integral from 1.39 to 3.4 of absolute value of cos 2x minus ln x minus 1 dx. And whatever I get will be the area of the shaded part. So let's do it. The calculator. This time I'll just go to, let me quit that. Alpha window. Let's select number 4. 1.39 3.4 math number absolute value cos 2x minus ln x minus 1 dx. So 0.668. So the answer will be 0.668.